Okay, so we are now back. We are going to finish the problem sets. Problem set use the Pythagorean identity. And here we have a problem. We've got the theta 1, angle theta 1 is in quadrant 2, and the sine of theta 1 is 9 over 41. Okay, so let me just quickly write that. We have theta 1 in Q2, and the sine of theta 1 is equal to 9 over 41. All right. Now, again, remember in Q2 is here, right? This is second quadrant. We know that the x coordinates are negative, but the y coordinates are positive, correct? So every point that's in Q2 is going to have a negative x coordinate and a positive y coordinate. Well, they want us to find the cosine of theta 1. Okay, so automatically we know that since sine is y and cosine is x, and since in Q2 all the x values are negative, we know this is going to be negative here, right? Okay, so now let's use the Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1, right, on a unit circle. Let's plug this in for sine theta. So we're going to have 9 over 41 squared plus cosine squared theta is equal to 1. All right, and if we subtract both sides, okay, this is going to come over as minus 9 over 41 squared, correct? So cosine of theta is this, which means if that's the case, let me see here. All right, so let's work this out first, see what this is. So 9 squared, of course, is 81, correct? And see here. So 41 squared is equal to 1,681. So this is going to be equal to 1 minus 81 over 1,681, correct? Now if I want to do the subtraction, I need common denominators, of course. So it's going to be 1,681 over 1,681, right? Common denominator, so it's got to be 1,681 minus 81 over 1,681, okay? And of course, I just subtract the numerators when my denominators are the same. So that's going to come out to 1,600 over 1,681. That is cosine squared theta. Okay? Well, to get cosine of theta, I don't need cosine squared, I need cosine. So I'm going to take the square root of both sides like that. And then I am going to get what my cosine is. So cosine of theta is equal to, well, I know that the square root of 1,600 is 40, correct? And I know that the square root of 1,681 is just 41. And I also know it's going to be negative because it's the x coordinate in the second quadrant. So my final answer is negative 40 over 41. So let's check. Let's go back to our problem. And let's plug in negative 40 divided by 41. Okay, and check. And that is correct. All right, and let's do the final problem. Okay, this time our angle theta 1 is in quadrant 4, and the cosine of theta 1 is 9 over 19. All right, so let me clear this. I'm going to clear the board. Yes. And now let's look at the new problem. We have okay, theta 1 is in quadrant 4, and cosine is 9 over 19. So theta 1 in Q4, and the sine Is it sine or cosine? Okay, cosine. So it's the cosine. So the cosine of theta 1 is equal to 9 over 19. Let me just make sure that's correct. And that is correct. Okay? So they want us to find cosine of theta 1. Okay, what is the sine of theta 1? Alright, so again, we're going to go into our Q4. This is Q4 right here, fourth quadrant. And we know that in the fourth quadrant, our x values are all positive, but our y values here are negative, right? So any point within this quadrant is going to have a positive x value and a negative y value. Okay? Well, we know that cosine is the x, right? And we know the sine value is y. So in the fourth quadrant, since the sine is y, remember, it's going to have negative, right? It's going to be negative. So we already know what the sine is going to be. And again, now let's use our Pythagorean identity. So again, sine squared theta plus cosine squared theta is equal to 1. Plug in our value for cosine of theta right there. So substitute it in. And we'll have sine squared theta plus 9 over 19 squared is equal to 1. And now we just have to solve for sine, right? So again, let's subtract both sides by 9 over 19 squared, like so. Okay? And now this time, I'm not going to evaluate this. Okay, I am going to do this though. Since I know that I have to subtract, correct? I know I have to subtract. And I can multiply 19 squared and then take the square root of 19 again, but why? Why do you want to square the 19 and then go back and square root it, correct? So I'm just going to make this one. Look what I'm going to do. I'm going to say this is going to be 19 over 19 squared. Does everyone agree that 19 over 19 is 1 and 1 squared is 1, so that this is equal to 1, correct? And then just minus 9 over 19 squared. Okay? So what I'm going to do is I'm not going to subtract the denominators. I'm just going to evaluate the numerators. So here it's going to be 19 squared. So 19 squared is 361. It's 361, correct? Again, well, okay, let's make it easy. So 361 minus 9 squared is 81 over 361, like that, right? Oh, something just happened. Just lost it. What just happened? Okay, so I just got it back. Whew. And that's going to be, okay, so 361 minus 81, bottom is 361, correct? So 361 minus 81 is 280, correct? Does everyone agree? Okay, it's 280, because 280 plus 81 is 361. Good. And now that is my sine squared. Okay, now, of course, we have to take the square root of both sides. So let's take the square root of both sides. And that's going to get me my sine of theta. And now the square root of 280, sorry. If you take the square root of 280, the square root of 280 is not a perfect square, is it? All right, so I can just go, okay, the square root of 280, but I know the square root of 361 is 19, correct? Like that. So I can simplify 281, see how far I can take this, or I could just leave that as an answer, because that is an exact answer, right? So if I wanted to, I could just write this as my final answer, and I think I'm going to do that. So let me just erase this, and I'm just going to box this and keep this as my final answer. But remember, it's negative here. So it's going to be negative square root of 280 all over 19. And I think I'm going to express that as my final answer. Okay, so negative radical 280 over 19. And let's just check. So negative radical 280 all divided by 19. And that is correct. Okay, guys? All right.